Okay, so in this video we're going to talk about logarithmic functions. And so basically what a log is, that's what we call it for short, is the inverse of an exponential function. That's what a logarithm is. We're going to look at a few things and talk about how to convert from one form to another, but basically a log undoes exponent. So we see here we have a graph. We have the exponential function here in green. F of x is equal to 10 to the x power. You see this green graph, and we see our exponential growth. This one is log, it's actually base 10. We'll start to learn a little bit more about that as we go on. But notice it pretty much is the same type of shape, just kind of positioned slightly different and rotated. Well, this line right here that is drawn in is the line that a inverse will reflect over. And so we know two functions are inverses if it's a reflection across this line. So what this means is the y's and the x's change spots, and you can redraw the new function. So they're inverses each other. You put them together, they undo each other. We've talked about that earlier on in this class. So here are two basic forms for exponential form and logarithmic form. So notice here we have a base raised to some power is equal to y. So in logarithmic form, we have our exponent is equal to the log of base by. So notice a few things here. Our exponent is what the logarithm is equal to. The base of the exponent is the base of the log. And what the exponential function is equal to is what the log is of. So log base b of y is equal to our exponent. So let's put the pieces together, and I got a quick trick to help us out. But so that means this guy is going to equal 2, which is the exponent. We're going to write the word log. Well, the base of the exponential function is the base of the logarithm, and that tells us, the base of the logarithm tells us, the base of the exponent, and that is of 36. So really, if I was to say this out loud, I would say log base 6 of 36 is equal to 2. But really what this is saying is if this guy wasn't here right here, and I just had x, I'm going to ask myself 6 to what power is equal to 36? 6 to what power is equal to 36? Well, that answer is 2. Okay? So the answer to a log problem is always an exponent. And if for any reason you're looking at one form or another and it doesn't make sense, the best way to start trying to figure out the problem is to convert from exponential logarithm or logarithmic to exponential and see if that jars something where you maybe see a solution. So we're going to go ahead and write each equation in logarithmic form. So, or exponential form. So I know that in a log, I'm equal to the exponent. My exponent is -3. I write my log, the base is 1/4, and it's of 64. So log the 1/4, log base 1/4 is 64 is equal to -3. Now I'm going to do a little quick trick here with this one. I'm going to number each piece. This is 1, this is 2, and this is 3. And if we draw a little spiral method, we draw the spiral through, it traces what we're supposed to put in for our logarithm. And so I'm going to rewrite this a little bit. So I'm going to start now. I'm going to write log. Number 1 is my base, so I'm going to put in 1/4. Number 2 is what the log is of. And number 3, the third number that I hit, is my exponent. And there we go. We are going to do the same thing with this guy. It's 11 squared, that's the second step, is equal to 121. We do this little spiral thingy to try and help us to put the pieces together. I felt that this has worked when maybe you forget putting it together. You use a little spiral as you work. I still use it a little bit to this day. And we'll do a little bit more conversion practice in some of these problems throughout the lesson. So you'll see the spiral thingy to help you out.